Welcome back, learners. So now we're going to jump to our second concept, whereby we'll be looking at cell as a source of electricity and then further look at battery as a group of cells. So to begin with the subheading or with the sub-idea, where we're looking at cell as a source of energy. We then need to know firstly that inside a cell, we know that there are certain chemicals, and then we also have different electrodes and electrolyte. Remember, electrodes, those are our terminals, the positive electrode and the negative electrode. Then our electrolyte, it is the solution or a paste that is used to conduct electricity. And then, the moment the cell is connected to a circuit, a spontaneous reaction will take place. So the moment I start connecting the two terminals, the positive terminal and the negative terminal with the wire, there's going to be a chemical reaction that is going to take place, by which electrons collect at one terminal, which is the negative electrode of the cell. So the moment now I start connecting my two terminals with the wire, the electrons will start now to be collected at the negative terminal of the cell, which is this part here. And then, remember we said that once the electrons are connected, or once the electrons are at the negative terminal, they need to move from one terminal to the other terminal. Or in other words, they need to move from one electrode to the other electrode through the wire. So, once now the electrons collect at one terminal, being the negative electrode, then those electrons are then withdrawn from the other terminal, which is your positive electrode. Then chemical energy in that case will then be converted to electrical energy. So, because we are saying that there is a chemical reaction that will spontaneously take place once I connect the two terminals with a wire. Now that chemical reaction will then be converted to electrical energy, because now my electrons are going to move to the negative terminal, and then from there they are then going to be withdrawn to the other terminal. And once that happens, that now produces our electrical energy. So in other words, I have taken my chemical energy, which was happening the moment I connected the wires, into electrical energy. That's now the movement of electrons from one terminal to the other terminal, or from one electrode to the other electrode. Then, the difference in potential energy between the terminals, also known as electromotive force, which is the EMF, or the terminal potential difference, or the voltage. So the difference in potential energy between the terminals, we can either regard it as our EMF, our electromotive force, or the terminal potential difference, or you can just even refer to it as just the voltage. Now that causes the electrons to move as an electric current through the external circuit. So in other words, we can take our terminal potential difference as the energy that is provided to the electrons to move from one point to the other. We do know that for you to also do some work, you need energy. So for these electrons to move from one point to the other, they need energy. And that energy comes in a form of your voltage, or the EMF, or even sometimes referred to as your terminal potential difference. So this terminal potential difference, or the voltage, is going to be moving now our electrons from the negative to the positive electrode. So it's going to be pushing our electrons from one negative electrode to the other positive electrode. Then the electric current then leaves and enters the cell again via the electrodes. Now remember, the movement of electrons from one point to the other, we refer to that as the electric current. So what's then going to happen is, as the potential difference pushes the electrons from one point to the other, the electric current is going to leave and enter the cell again via the electrodes. So the electrons are going to be leaving this cell, going through the wire, coming back and entering the cell via the electrodes. So the movement of electrons from one electrode to the other electrode will be our electric current. Then the EMF, it indicates how much energy is stored in the cell and how much it is transferred to the charges. Remember, the charges are your electrons as they leave the cell. So when we are talking about EMF, we are talking about the energy we're talking about the amount of energy that is stored within the cell, or that amount of energy that is transferred to the charges. And remember that those charges are referred to as electrons as they are leaving the cell. Then that EMF It is measured in volts, which is denoted by V, capital letter V. And then the charges can move through the external circuit and transfer energy to electrical appliances to provide power. So as our charges, as our electrons are moving from one point to the other, they are going to be transferring energy to the electrical appliances. So all the appliances that you are using at home, be it your kettle, be it your cell phone even, or the remote, that is because the electrons that are passing through those wires, they are transferring energy into that electrical appliance, being the remote or being any other appliance that you are using. So now, as the cell continues to be used, so if you keep on using the very same battery or keep on using the very same cells over and over again, the chemicals that are going to be depleted, so the chemicals inside those cells or the chemicals in the battery as the group of cells, it is going to be depleted and the cell or the battery eventually is going to go flat. Remember, a battery is going to be a group of cells. So if you're using just one cell, then over time, the chemicals that are stored or the chemicals that are found inside that cell, they're going to be depleted. And once that happens, that cell is going to be flat. It will eventually go flat, which is why at some point you might need to then replace the cells. Then, when two or more cells are connected in series, they form a battery. As we have said, a group of more than one cell, it is going to be called a battery. If it's just one, it's a cell. More than one, that makes up a battery. So then, cells may be connected to one another in different ways in order to form a battery. So the cells can either be connected in parallel or they can also be connected in series. So by the different ways, we're talking about a connection either in parallel or a connection in series. So when we're forming a battery, and that battery is connected in series, that means the positive terminal is going to be connected to a negative terminal, and so forth and so forth. So it's going to be positive, and negative. Whereas when we're talking about a parallel connection, again, to form a battery, a negative terminal is going to be connected to a negative terminal and another negative terminal, and then with regards to the positives, they'll also be connected to each other. As we can see on this picture, negative to the negative and positive to the positive, only in a parallel connection, whereas in series, it's negative connected to a positive, and then that positive connected to a negative up until you form the battery that you want that contains the number of cells that you want in that particular battery. So now we need to look at what happens when our cells are connected in series. So we should also know that a positive pole, when you're talking about a series connection, a positive pole is going to be connected to a negative pole of another cell. So one positive pole of one cell is going to be connected to a negative pole of a different cell. So remember, that connection is going to form a battery. We can have as many cells as we want in that battery. However, the most important thing to remember is that a positive pole must be connected to a negative pole of a different cell. Now, again in series, the total EMF of the battery, so the battery that you have connected with a positive and a negative in a series connection, the total EMF of the battery in this case is going to be equal to the sum of the EMF of the individual cells. So on this picture alongside, we are told that the EMF of the entire battery is given to be 6 volts. And as we can see, we have 4 cells that are connected to form this one battery. So that means each of these cells has an EMF of 1,5, so that when we add all these 1,5s, we are going to get 6. So 1,5 plus 1,5 plus 1,5 is going to sum up to 6 volts. So each of these cells has an EMF that is equal to 1,5 volts. So as the statement says, the total EMF of the battery is equal to the sum of the EMF of the individual cells. So in addition to that, a battery of 2 or more cells supplies more energy to the charges that are moving through the circuit, and that also generates a stronger current than a single cell. So that means the more cells we add in a battery, the more current or the stronger the current that is going to be generated within that battery. So a battery of 2 or more cells supplies more energy as compared to just having a single cell. So again, we can have 2 cells that are going to supply a certain amount of energy, And if you keep on adding another cell to say now 3 cells, and then that energy supplied by the 3 cells is going to be much more bigger than the energy supplied by the 2 cells. So the more cells we add in a battery, the more energy is going to be supplied to the current. And when that happens, that is going to generate a stronger current as compared to a battery that has less cells as the subsequent one. So cells in parallel is different from the cells in series. Now in parallel, we have that a positive pole is connected to another positive pole. Remember, we're still talking about the parallel connection. And then also a negative pole is connected to another negative pole of a different cell. So when we're comparing the parallel and the series connection, you find that in series, the positive pole is connected to a negative pole of a different cell. And then in this case, the positive pole is connected to a positive pole of a different cell. And again, the negative pole is connected to a negative pole of a different cell. That's only if when we are talking about the parallel connection. So if that is the connection, then what about then the EMF of the battery, or what about the EMF of the cells? So in parallel, we find that each cell should have the same voltage. So each cell in parallel has the same voltage, and the total EMF of the battery is equal to the EMF of one cell. So now, if we are given that on this picture alongside that, the total EMF of the battery is 1,5 volts. That means also that even each cell has the EMF of 1,5. So one cell is going to have an EMF of 1,5 volts, and we also have 4 cells in this case, so the sum of all those 4 cells will still be equals to the 1,5 volts. So the statement says each cell should have the same voltage, and the total EMF of the battery is equal to the EMF of one cell. So the EMF of the entire battery is equal to the EMF of just one cell. So that means the battery, the cells that are connected in parallel, they make up one cell that is equal to 1,5 volts. Then, when we are now adding when we're adding more cells in parallel, any number of cells in parallel generate the same total current. So because each cell has the same potential difference as that of the entire battery, that also means they're going to generate the same total current. So the more cells that are added in parallel, the smaller the fraction of the total current each cell generates, and the longer they last. So in series, remember, the more cells we add in series, the stronger the current that is going to be generated, whereas here in parallel, the more cells we add, the less strength of the current that you're going to be generating. So by so doing, remember, those cells, they are going to last longer, and they're going to generate a fraction of the current, and that makes them to last longer and longer. So in closing, these are the most important things that you need to remember. Number one, the connections in series, positive to negative and positive to negative in a series connection. Whereas in parallel, positive to positive, remember that those positives are coming from 2 different poles or 2 different cells. And then again, negative to negative, again coming from 2 different cells. Then in series again, we need to also remember that the more cells we add in series, the stronger the current that is going to be generated. And we also need to remember that the more cells we add in series, the amount of potential difference is also going to increase. And because of that, the stronger the current that is going to be generated in that particular case. Whereas in parallel, the more cells we add, the lesser the current that is going to be generated, and by so doing, the batteries, or rather the cells that are going to be used to generate that current, they're going to last longer and longer because they are generating lesser and less current. So I hope you enjoyed learning about cells, particularly the difference in terms of the parallel connection and the series connection. And until I see you next time, goodbye.